Hello everyone, welcome to physics tutorial. Today we are going to be looking at a concept in physics that is um, very essential when it comes to experiments. Now, physics is a very important science subject that requires every scientist to be able to present their data logically on a graph. So I'm going to take you through the introductory graph principles. So we know that a graph is it's a drawing that is bounded by two axes, which is the horizontal axis and the vertical axis. So, but basically in physics, aside from the fact that we have quadratic graphs, we have exponential graphs, we also have straight line graphs. What we intend to do today is to show that in physics, most of our graphs are transformed from any way it is to a straight line form. So today I want to show you some conversions from any form of equation to a straight line graph. But before then, we need to establish this fact that a graph is like this. This is popularly known as y, which is in the mathematics. But in physics, you don't name your graphs y and x. You name it according to the variable given to you. All right, so let's use y and x, for instance. Now, according to the straight line equation, we know that in linear equation, we have that y is equal to mx plus c. Now, if y is equal to mx plus c, we say that y, which is on the vertical axis, this is our, let's call it y variable. Then on this part, you can see, let's call this x our x variable. Now, what are the other two constants or two variables in our equation? So the m stands for slope and the c stands for intercept. Now the slope is also known as the gradient. Now the slope is what gives us the relationship between the y and the x. Now take for instance, you plotted a graph and you have a straight line. You find the slope. So this angle or this triangle is called the slope. All right, so in transformations, when the intercept is 0, we are going to have our graph starting from the origin. So let me give you some pictograms of how graphs look like. So assuming we have y is equal to minus m x plus c. Okay, in this instance, our slope is negative. We could also have that y is equal to mx minus c. In this instance, you see that the intercept is negative. But then if c equals 0, that means we are going to have y is equal to m and x. So the implication of this is, so for the first one, probably you have a graph that looks this way. So this is minus x, this is minus y, and this is y. So some graphs could come in this form where it is like this, and then you take your slope in this manner. So this satisfies the equation that your equation, the slope becomes what? Becomes negative. So because we have a positive intercept here, what we usually do is that when the graph is plotted, you're going to have a straight line graph cutting through. So you're going to have a plus c here, and then when you draw your slope, you have your minus m. So this satisfies this first equation. All right, our intercept is always taken on the y-axis. Don't forget, intercept is always taken on the y-axis unless otherwise stated. In some questions, you can ask you to take intercept on the x-axis. So this is 1. So let's check for this. Y equal to mx minus c. So I have a graph like this. Now, look at it. We have the positive y-axis, positive x-axis. Our slope is supposed to be positive, but then the graph is going to take a negative intercept, meaning the graph will come like this. So you take your minus c here. This is y. this is x, and you have your slope, something like this. Then, but then if intercept is equal to 0, whether it is this form or it is this form, or if it is this form, once your intercept becomes 0, that means the graph starts from the origin. So you are going to have a graph that looks this way, starting from the origin. So this is your y, this is your x, this is your m, and this is your c, starting from the origin. Okay, so let's take some examples from the explanations I gave. So I have 3 examples. This is an equation of period for a simple harmonic motion, and then this is optics, this is electricity. So I want to transform this equation. So assuming you are given an equation like this, and you are asked to plot t, which is period, against L, you need to make this a straight line equation such that you would have your y components, you have your m components, you have your x components, and you also have your c component. Now, to plot t against L, you can see where L is. So the first thing to do is t is equal to 2 pi square root of h minus L all upon g. Since we are plotting t against L, our t is already on where it's already where it is already, so we don't have a problem with it. Now, how do we take away this square root? What we do now is we take the square of both sides. That's what mathematics teaches us. So we are going to have that t square is equal to, this becomes 4 pi square. So square cancel square root, you now have h minus L all upon g. Good. Now, having this, we're going to expand this bracket. So we're going to have t square is equal to, open this bracket, you have 4 pi square h minus 4 pi square L. Everything is over g. All right, so in elementary fractions, we know that this is the same thing as t square is equal to 4 pi square h over g minus 4 pi square L over g. But don't forget, the question says t against L. Now look at where the position of L is. Now we are trying to transform this to give us a straight line. And this is our y component, this is our x component. So we are going to rearrange it. So you are going to have something like this. T square is equal to, when you bring this, it will become minus 4 pi square L g plus 4 pi square h over g. Now, all right, so after the rearrangement, we brought this to this place. The reason why we are doing this is so that we are going to have, so here we have t square is equal to minus 4 pi square L over g plus 4 pi square h over g. Now remember our linear equation, y is equal to mx plus c. Now when we do a comparison with this equation, you can see that this y is our t component. Now this is the component of the slope, but our x component is L. So that means the whole of this, everything before L becomes our x, and then plus, and then c. So from here, we can say t square is equal to minus 4 pi square over g dot L plus 4x squared over g. So you can see now that this is your y. The whole of this becomes your m x plus, this is our c. So at the end of the day, you have y equal to t square, x is equal to L, m is equal to minus 4 pi square over g. Your intercept is equal to 4 pi square h over g. So when you plot this graph from the slope, from the value of the slope, you can find acceleration due to gravity. From the value of the intercept, you can find acceleration due to gravity. You can also find h, and then that's that. All right, so welcome back. This is number 2 now. So we are going to plot u object image distance or object distance against image distance. Okay, so here now we are doing u against v, but you can see that u and v are in the same place. So simple mathematics tells us we're going to do what we call and collect the like terms, even though there are no like terms. So we're going to have 1 over u is equivalent to 1 over f minus 1 over v. But we are plotting u against v. So we're going to have 1 over u is equal to, so you rearrange. You bring this to the other side, you have minus 1 over v plus 1 over f. Now, if that's the case, we are plotting u against this. So we can equally write this as 1 over u is equal to minus 1, right? 1 over v plus 1 over f. So you can see that this, our y is equal to mx plus c. Our y component is 1 over u. Our x 1 over v. Then our intercept, our slope suddenly becomes minus 1. And our intercept c is the focal length. Right, that is that. Then you can try this for me. V is equal to E minus IR. This is electricity. So we are plotting V against I. So it's related to this. You can do this and get whatever you get as your answer. You can post it, and then if there's a mistake, I will come back for correction.